Okay, so you just watched the video that we talked about all the proportion formulas. So now I'm going to move over to the mean formulas. And I still want you guys to not only compare the one sample formulas to the two sample formulas, but I also want you to compare the relationship between proportions to means. So compare kind of both directions. So over here, again, I'm going to actually split this and say for a confidence interval, on the one sample side, we have the mu of the x bar is equal to x bar, because we, again, don't know the true value. So we're going to be having to use the sample. And the standard deviation of all the x bars is the sample information, s of x over the square root of n. Okay, so again, that's standard error, which makes us actually use a t interval instead. But on a significance test, the mu of the x bar, we can actually use the claimed mu, the true mu that they're claiming, because we're building a sampling distribution off of that claim. And then we're going to do the standard deviation of the x bar. It's actually the same as the standard deviation over the square root of n, which again is what makes us use a t interval. So that's just if you were actually building the sampling distribution. Now, a one sample t interval for means, we are looking at the general formula. Well, it's the exact same general formula that we used over here for all confidence intervals. Statistic plus or minus the critical value times the standard deviation of the statistic. So if I fill in those blanks, well now, because we're dealing with means, the statistic is x bar. Plus or minus, remember, because we use sample data, we have to use a t star, and then we have to say times s of x over the square root of n. Now, and because of the t star, remember to also list your degrees of freedom, which is always the sample size minus 1. On a one sample t interval for means, remember, it's that test statistic formula is equal to the statistic minus the parameter divided by the standard deviation of the statistic. And as you can see, these are the same across the board. It doesn't matter if you're doing proportions or mean, it's the same. But we take that general formula and we plug in the specific pieces. So the test statistic this time is the t, and that's equal to a statistic of x bar minus the parameter of mu divided by the standard deviation of the statistic, which in our case is the standard error formula. And again, we have to say degrees of freedom because we're using a test statistic t. So these are all from the last two chapters when we just dealt with one sample. Again, these are the formulas for the two sample. We just wrapped up using these formulas. So I should have actually probably split this also, because on a confidence interval, we're forced to use the sample data. So that's going to be x bar 1 minus x bar 2. And for the standard deviation of the sampling distribution, we saw that formula is it's actually the variance of the first divided by n1 plus the variance of the second divided by n2. All right, and then when we come over here to a significance test, it's very similar, except at the center of the sampling distribution is mu1 minus mu2. We're assuming that the true proportions have no difference. So then the standard deviation of x bar 1 minus x bar 2 is, again, the same formula that I just wrote to the left. The variance of 1 over n1 plus the variance of the second over n2. So this is how we build those sampling distributions. When we actually get into doing a confidence interval, we say it's a two sample t interval for means. Again, it's that general formula, statistic plus or minus the critical value times the standard deviation of the statistic. Notice that's the exact formula I wrote every single time I said general formula for an interval. We can then plug in our specific pieces. The statistic we're dealing with is the x bar 1 minus x bar 2. We're comparing the two statistics. Plus or minus a t star for the critical value times the standard deviation of the statistic, the variance of the first sample over n1 plus the variance of the second sample over n2. Remember to list your degrees of freedom since you used a T-star. And to find the degrees of freedom, this is where I said to use your calculator. The formula is too complicated. Just type it in the calculator and write down the value from the calculator. Okay. On the two-sample t-test for means, again, the general formula is the same one we've always used. Test statistic equals the statistic minus the parameter divided by the standard deviation of the statistic. So we get the specific formula then is the test statistic is t equals a statistic of x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by the standard deviation of the statistic, which I've already listed, s1 squared over n1 plus s2 squared over n2. Again, because it's a t, we have to use a degrees of freedom that we'll have to use the calculator on. Okay? So, this is all the formulas. Again, the majority of the formulas that you guys are going to use for this chapter is the two-sample information. We're doing 2 samples this chapter, but I'd like you guys to be able to do all the different comparisons, comparing 1 sample to 2 sample in each specific kind, 1 sample to 2 sample, but then comparing proportions to means, comparing proportions to means. Okay, really know these general formulas and how to plug in those pieces. So I hope you guys find this useful. I want you now to transition into doing the review. I will go ahead and have the review posted on the YouTube page before you have to take the test. So I want you to do the review yourself, but then you can go and watch my little video on the Chapter 10 review to answer any questions that you guys have. So good luck without me. I know you guys will do great. Make me proud. Okay, we'll see you later. Bye.